Welcome back to Area Diesel Service. Today we have another exciting collaborative effort with fellow YouTube content creator CNC Equipment. If you didn't come to us from CNC Equipment, please go over there, check them out, tell them that we sent you. CNC Equipment is an independent heavy equipment service dealer and repair facility. They are the undisputed heavy equipment repair content creator on all of the YouTube. These guys are doing some significant projects and they make some very hard and heavy repairs look very simple and easy on their channel. If you're into that type of content, go over there and check it out. Watch what these guys are pulling off. And they also do a fair amount of restoration type work. They'll take a crusty old clapped out machine, bring it in, overhaul it, repaint it, resell it, and the transformations that happen on some of these machines are unbelievable. Today we have in this box a fuel injection pump off of one of Clint's personal machines, a 4610 SU Ford tractor. SU variant being the super utility, and I believe the story is that a 4610 SU uses the front end off of a 3000 series tractor, and it makes it a little bit shorter and a little bit more agile machine. This particular machine has somewhere in the neighborhood of about 4,000 hours on it, and it checks in somewhere in the neighborhood of about 4,600 pounds. These machines, 4610 and the SU variant, were manufactured for the majority of the 1980s, and this particular machine, I believe, had a build date of 1985. Could have been manufactured in Belgium, England, or Michigan, and this particular tractor with a serial number starting with the letter C, indicating that she was manufactured in the Romeo, Michigan plant. Powered by a Ford 201 cubic inch, 3-cylinder, naturally aspirated, direct injected diesel engine. That is somewhere around 3.3 liters for those of you on the logical system. And she's factory rated somewhere in the 60 horsepower vicinity. So the complaint is that the injection pump is making oil and leaking fuel. If you're not familiar with the industry term making oil, go over and watch the guys at Hamiltonville Farm. I think everything that those boys own makes oil, but effectively what that term indicates is that the crankcase or the oil, engine oil system is being diluted with diesel fuel, right? To make an oil, the oil level comes up because the crankcase gets filled with fuel, and the majority of the time that comes from a faulty injection pump. You can see it out of engine-driven supply pumps. You can see it from cylinder head issues or heads that have integrated fuel return circuits. But most of the time from this era, it's a pump issue and she's making oil. Never a great idea to dilute your engine lubrication with diesel fuel, but it does happen all the time. Doesn't generally cause significant damage as long as you catch it and as long as you address it. Enough blabbing, we're going to get into this pump and see what we've got. Clint and the boys at CNC always do a fantastic job packaging these and getting them to us safely. If you are going to send us something, please take a little bit of time and a little bit of care. And hopefully Clint has done his usual package job here. Got something in there that's not a pump. She's full of foam peanuts, packing material right there. So safely packed with adequate packaging material, tightly wrapped in saran wrap so it doesn't leak. A little bit of swag from the boys at CNC. Thanks, guys. So in here, we should find what we call a DPA pump. And in the era when it was originally manufactured, it would have been under the Lucas or CAV or Lucas CAV brand, which was later absorbed by Delphi. So today, service specifications, subcomponents test plans provided by Delphi, right? Delphi is a global brand you've likely heard of, and we are a Delphi factory authorized service dealer. And oddly, Ford, at least the tractor division, was gobbled up by New Holland and then later by Case IH and formed Case New Holland. A little bit of the history lesson there. And Clint did a fantastic job as per usual, packing it, wrapped her in a pig mat, and it made it to us safely. Lucas DPA Pump, a very robust injection pump. This one Clinton doesn't believe has ever been touched. It's got 4,000 hours on it. It's 40 years old. Still functions perfectly, but it's making oil and leaking fuels. The shmoo, the proverbial shmoo, is always a good indication of a fuel leak. Looks like potentially top cover gasket leaking a little fuel, and then dust sticks to it, and that's where we get our shmoo. So leaking fuel, making oil is almost always back here at the drive shaft. So this mounts to the backside of the engine timing cover. The engine drives it here in this fashion, and there are seals inside of this. DPA pumps have two variations, either one or two seals in here, one keeping oil in the engine and one keeping fuel in the pump. But a lot of them also just ran one seal that did both. This one is the two seal variety, and one of them has failed. The one seal variant, when you get the pump off, you can replace that seal on the bench, reinstall the pump. The two seal variant requires complete scattering of the injection pump. You can do one from the outside, but the other from the inside. Rotary style distributor injection pump with an integral vane style supply pump. So engine drives the pump here. There's a little vane pump back here that draws fuel and charges the injection pump. And then there's a cam ring with plungers that does the high pressure pumping, and a distributor head that pumps it out to the specific cylinders here. Fairly simple min-max governor in the top. That's it. Very, very similar to a Stanadyne pump. I don't know who stole whose design, but there was obviously some shared secrets going on there. Relatively simple to diagnose on the engine. If your engine is turning the pump, and if you are supplying good, clean fuel to the injection pump, and if your return circuit is free and unrestricted, this thing should be pumping fuel to the injectors. If it is not, and you have those three things, it's in the pump. That begs the question, do you go in or do you send it to a fuel shop? Those of you that have seen Clint's channel, you know that Clint and Kevin and the crew are all extremely capable mechanics. If they opt to yank it and send it to AreaDieselService, I think I would probably have the same opinion. The part count inside of this injection pump exceeds that of the entire engine, right? There's so many little widgets in here. If you don't do it every day, it's hard to know where everything goes, what everything should look like. The tolerances are extremely precise. There are folks that successfully do what we call a tailgate rebuild. You know, we don't hate on anybody for trying to save a buck. Gasket kit for this pump is relatively reasonable, and if that's all it needs, have at it. But remember, if you send us the proverbial bag of parts, there is no discount for you saving us the labor of disassembling. No discount there. In fact, sometimes it ends up costing you more to have gone in first. Anyway, way too much rambling. Master Gracey is going to be your technician on this pump, and I think we're going to give you the full feature ride along, and he'll take you through the entire process of rebuilding this pump.
Hey everybody, I got this pump here for CNC. It is what I would consider a very typical Ford pump. We got some things that are kind of indicative to Ford pumps. You have a taller end cone compared to other CAVs. This is a little taller, and also it takes a mounting O-ring rather than a flat gasket. Other than that, it's pretty standard. Ford CAVs are fairly common to have come in here. I got it capped up here. I haven't really dug into it very much. All I did was look into the side of it, and it looked actually pretty clean. It had this little brass piece in this fitting here, which I dug a grommet out of. and got it capped up. He said that it was getting fuel in the oil, it was gaining oil. So most likely his main problem is going to be this hub seal, which is obviously a pretty common problem. Another common problem with DPAs is they leak out of your throttle shaft and your shutoff shaft. The sleeves can get grooves in them to where then the O-rings don't seal and the O-rings just go flat. It's just how it is. It's a pretty common problem with DPAs. This one, I can tell it was maybe leaking a little bit, but not quite as much as what I've seen in the past. I'm hoping that these sleeves are going to be good and I can actually reuse this top cover, because I do have to replace these top covers fairly frequently. I'm happy that I can actually do something different for you guys. Instead of just Stanadyne pumps, you can see something a little different since we haven't ever done a DPA yet. And also with doing it with CNC, they got me this nice hat, so I'll be able to put that to use on the boat. Anyways, I got it capped up. I'm going to get it cleaned up, blasted. I wrote my fitting directions down, stuff like that. Wrote the paint color down so I don't forget. But overall, this is a pretty common fitting direction, because a lot of times, each DPA, these discharge fittings will come in different directions, where this is honestly a pretty common setup for a 3-cylinder, which after doing a few hundred of them, you get to remember some of these things. Overall, it's ready to get cleaned up. Once I bring it back in here, we'll be ready to take it apart. I got it all cleaned up now, got paint blasted off of it. Don't really notice anything too crazy just by getting the paint off of it. I will say I tear these down pretty similarly to how I do Stanadyne pumps, kind of start at the top, work my way through. Because really, DPAs and Stanadyne pumps are honestly fairly common in how they function. They are designed differently, but you still have, throttle lever, shutoff lever, your governors up top, transfer pump, which is pretty similar between both pumps, head and rotor is pretty similar between both pumps. You have, this is the return on Ford pumps. A lot of times it's here on the front of the pump. It's just design change. And then DPAs have a bolt-on advance, where most Stanadyne pumps have a housing that has the advance already made into it. Some early Stanadyne pumps have a bolt-on advance, but it's just not as common. Start here, remove some of these fittings, and see if we can find anything too crazy. There was no gasket on that. Interesting. There's normally a gasket on that top fitting. Surprised it didn't leak. The high idle and the low idle screws I don't normally mess with, just because then on the stand I can kind of see how close they were. Little gaskets here. Now, there is a spring code on DPAs. It'd be number 7, which I'll explain that whenever I go to rebuild it. That's your shutoff bar. Goes in here, so as your shutoff lever moves forward, this is normally held up, so then that pushes that forward and then pushes your metering valve to shut off. Low idle spring and peg, your governor spring. Get these out of here. It's kind of hard to tell. I think the top cover is going to be okay. I do see a little bit of wear in there. I'll know more once I clean it up. But, I mean, this pump was pretty clean, which is a good thing. Worry about that later. There's always 2 O-rings on these shafts, which these ones here are pretty flat, pretty worn out. On these bolts here, this middle bolt and these 2 longer bolts, they have these little locking plates that you gotta bend back, which these don't really matter because they come in the kit, so it'll get new ones anyway. So once I remove these 3 bolts here, then this whole plate will come off, which will then let that metering valve come out. And all this just pulls out. That's your metering valve. Again, pretty similar to a Stanadyne pump, has a metering valve that regulates your fuel. They are designed differently, but overall they provide the same function, which that one there has some wear to it. So here's your inlet. This is definitely, again, it provides the same function, but it's definitely designed differently. So, as you can see, it's all more individual pieces rather than one solid piece. There's just your inlet screen there, which that gets trashed because it comes new in the kit. But yeah, basically you have a piston that goes up and down that then has a spring resistance. Again, basically then you just screw this piece here, has a little screw on it, it goes in and out, and you regulate that, and that determines how much transfer pressure you get on this particular one. A lot of the other ones just use step plugs, so the taller the step, the more transfer pressure you get. Little gasket right here on the end of this regulating sleeve. These end plates a lot of times will wear out, but this one here, you can see just a touch of wear there, but honestly, it's in pretty good shape. Definitely can be reused. There's just an O-ring. And then you have your liner and then your blades. So, older style Stanadyne pumps will use these. I guess not necessarily old. Oh, I guess it is the older style. They'll use these one-piece blades, and they'll use a different liner, but it's the same concept, just a little different design. These are just banjo bolts. These banjo bolts are actually pressurizing, so they have a little piston and spring inside there. A lot of CAVs, DPAs have this. There are some that just use an open one that don't have a pressurizing valve in it, but that's a pretty common deal right there. These here are just your head locating bolts. Normally one bolt always has a bleeder. The only time that it really doesn't is a lot of times on John Deere DPAs don't have bleeders all the time. Sometimes they will, sometimes they won't. I gotta get a tub and drain the fuel out, which the fuel looks really good. So that's a good sign. Got the fuel drained out of it, so I don't make too much of a mess over my bench. This here on this Ford pump is the return boss. It has a little ball in here that's has a spring behind it. A lot of times these plates will get loose and then you'll have to replace them. Honestly though, he got kind of lucky because this is the steel version. They made a aluminum version back in the day, and what happened a lot of times is that this embossment here would break loose and then it would just spin and it would leak, and it just wasn't a good design. So then they started making them out of steel, and I haven't had too much issues with the steel ones. Even the aluminum ones would have the balls break out more than what the steel ones will. So I got kind of lucky there. I have to order those quite a bit. A lot of the aluminum ones just aren't good. So here's the advance. That there is, I'll go to read my advance on the stand through that hole there. That's why there's a plug. And that, other than that, it really serves no purpose. So this is the spring side. The other side is a power side, just like a Stanadyne pump. But DPAs always use shims. It's like this is a really thick shim, and this is what I would consider a more medium-sized shim. But even then, you can see that's pretty thin. That's pretty thick. They make thinner ones than this. And there's also a size in between this one and this one. So I can kind of tweak it on the stand to whatever I need, depending on what my advanced spec is. This one just has a single spring, which that's pretty common. This will probably have a check ball in it. Nope. Okay, so this one here, the ball is on the inside. Sometimes these styles will have an external check ball that'll fall out, which also comes in the kit. These O-rings here are definitely worn out. They're super flat, pretty brittle. So it was definitely in need of some repair. Which I would say that's probably most of my DPAs that come in are leaking. That's their biggest complaint. Between the O-rings going bad and bad fuel, those are probably my two main problems. That piston there is nice and clean. It has some wear to it. A lot of times these DPA pistons and housings, even if they have some wear, generally they'll work still. So I don't worry about them too much. This here is your cam screw. Give it a couple little taps. This here is an actual special tool. So you can see that is shaped exactly like that bolt. A lot of guys out in the field have to grab onto them with vice grips or whatever, but of course I got special tools to help me out. It just comes right out. Generally those CAV cam screws will come out. Every great once in a while you'll have one that won't, but for the most part I don't have too much trouble with them. Take the nameplate off. Of course I'll put a new nameplate on it, so that's really no big concern. Now let's see if I can get this. Okay. Come on. There we go. Okay. A normal head O-ring on this. Yeah, and see that O-ring there literally just split apart like it was nothing. So these things here are just toast. So this here is a 4-roller CAV head compared to a 2-roller, which is the same for Stanadyne pumps. You know, Stanadyne pumps have 2 rollers and 4 rollers. These are a little different just because you don't have to do centrality and all that stuff with these. But other than that, it's, again, pretty basic design. The ends on these CAV pumps come off. I got another special tool. Of course, these just get lightly torqued down, so that just comes right off, gets threaded in, which I'll have to do another check with that once I go to build it. Now, this, I've referred to them as cheek plates, but they're basically your fuel plates. You have one on either side. On this one, you can see, let me get a pic here. So, these grooves right here, those are identification grooves, and that determines how much fuel these plates will make. So it basically allows the rollers to come out further. So like my top plate is 2 longs and my bottom plate is 2 shorts and a long. So depending on what combination, whether you have 2 longs, you know, a long and 2 shorts, you know, they get you into different fuel ranges. So this has 2 pins to help hold that in, and then you got your rollers. And generally these plungers go in a certain way, which these are in that way. Got your 4 plungers. Other than that, I don't ever take this off. You can't, I guess I don't. I do if it's really nasty, but since this one here is pretty clean, I'm not really going to worry about it. The rotor on this actually looks pretty good, so I'm not too concerned that it won't make fuel or make cranking. I don't do anything more to that other than just clean it up. Now, I have the cam. Cam just slides out, which the lobes on it look pretty good. So we'll be able to reuse that just fine. There's a snap ring in here that'll come right out. That's more just for timing, and it helps hold the cam from going in too far. And then we have a bolt in the center of the hub, which holds the hub to the drive to the inner shaft. Break that loose. Okay, and this one here I didn't even have tap apart. A lot of times I'll have to screw the screw back in a little bit and hit it with the hammer, and then it'll separate, but this one came right out. There's a bolt, there's a spring washer in there, and then there's another flat washer in there, but a lot of times it doesn't come out. Now, one thing I'm concerned about definitely has some wear to this, which could have been contributing to the leak, but I bet you is more because of the seal being bad. Because you can see right here, this line, it's kind of hard to tell, but it definitely has some wear right there. You can see that ring go all the way around. I'm not too super concerned with it. These seals in here are honestly pretty good, as long as they're new. It's not like I can really catch that groove with my fingernail. I know I can feel it, but I don't think it'll cause a problem. Inner shaft, which has your weights, thrust washer, thrust sleeve. This one here is a 2-piece. So cut this. That's just an O-ring that holds this together. This will slide out. That's your inner shaft. The weights fall out, which the backs of these weights will wear out, which these ones here definitely have some wear to them. Yep. So see, I'm not going to be able to reuse these weights. Most likely that's going to be something I'm going to have to order. I might have some laying around, but I just don't know if I'm going to have any. This thrust washer here has some wear on this side, but honestly what I can do is just flip it over and it'll be just as good. So I'm not really too concerned with that. Now, this thing here, this plate comes off, and then there's 4 cushions underneath here, because then this comes out. And then these cushions, as I drop one. So you have the 4 cushions that are in there. These cushions I always replace, just because otherwise it's kind of like a flex ring in a Stanadyne pump. It keeps it from wanting to jiggle too much. If you get too much movement in there, then it can make your RPMs kind of flutter. So that's why I just don't even mess with them. And they're fairly cheap. Here we go. Yeah, I mean this. That seal there is pretty well, it's pretty well toast. Yep, it's pretty flat. It's also pretty, I mean, it's really hard. It's not pretty hard, it's really hard. Yep, that seal is gone. Which that's pretty well what I figured was what I would find. Other than that, that was definitely his main problem, was the fact that he just needs new O-rings and seals, because the ones that are in it are way past their lifetime. So overall, the pump was in decent shape, honestly, but definitely needed some love. Get these parts cleaned up, and then I will lay everything out and show you guys kind of more individuals, and then I'll go through some of the parts, see what I'm seeing with them, see which ones I'm gonna have to order. I'm gonna look for these weights while I'm at it. Hopefully I got some laying around, but normally if your weights are worn out on the heel, you might be able to see it. You can see it a little bit right there, but as the wear creeps up, then it doesn't action as good inside of your weight cage. So this action starts to fail, and then your governor response goes, and it's kind of a trickle effect. But normally, if these wear out, then your weight cage is also worn out. So I'm going to see if I got any, but there's a very likely chance I'll have to order that. I'll get this cleaned up and laid out, and then we'll go from there. Okay, so I got all my parts back in here, got them all cleaned up, got some parts buffed up. I was able to find a weight cage and some weights, so that was good. So basically now I'm just going to lay everything out, double check everything, and just kind of determine, okay, what parts are good, what parts are bad. Which, of course, whenever I tore it down, I didn't really find too many bad parts, thankfully. Yeah, that weight cage is a lot better than this one. That one there is just plain wore out. The liner's worn out. It has some grooves in it. Rotor looks good. There, don't really worry about. At least now I got 6 good weights too. Yeah, because these other ones they're just toast. And of course now I'm just kind of laying the parts out in groups. Makes it easier for me whenever I go to put it back together. A lot of these parts don't ever wear out, so a lot of them I don't really even have to look at, but there are some that I have to double check on. I'll probably replace that metering valve. I'll see if we got one. Also with these pressurizing valves, I like to check them because I have had the springs in here break. So like I said, there's basically just a piston and a spring in there, which all these feel real good. Usually you can tell whenever they're broke because they feel loose or they feel real soft. Rollers look good too. These rollers will wear out, but normally if the rollers are worn out, the cam's worn out, and the cam looked fine, so. Luckily the pump was clean. That helped out a lot. Makes it easier to tear down, makes it quicker to tear down too, honestly. His main housing looked fine. His top cover, it has a touch of wear inside these sleeves. And it would probably be still good for a while, but I did have a spare one that's basically brand new. So I'm going to use this one instead just to make sure. End plate was fine, like I said earlier, that doesn't have much wear at all. Sometimes with these, what I've done, I take that roll pin out and I'd get a real flat piece and I put a piece of sandpaper on it and I go back and forth and kind of smooth it back out. And I've had good luck with that, so they can be saved if they're not too terrible, but there have been times where They're just too far gone. Head and your rotor, drive shaft, well, I guess it'd be, yeah, that's kind of your drive shaft, inner shaft, drive hub, cam ring, cam screw, weight cage and weights, thrust sleeve and thrust washer, pressurizing valves, some banjos, rollers and shoes, plungers. This is also the rotor end. You got your advance and your spring, your regulating assembly. This here's your return fitting. Then you have your governor plate, governor spring, shut off bar, your levers. So that's kind of a little bit of a rundown of what we got. So basically, with this pump here, we determined that the O-rings were bad, the seals was bad, which the seal is what was pretty well causing this problem. But we also determined that his transfer pump liner and blades are worn, the governor weights and the weight cage were worn out. His metering valve has some wear, which it would probably still work, but it's just kind of teetering on the edge. Transfer pump's piston has some wear to it, and his top cover has some wear to it. So really, a lot of these are common wear items, except for like the governor weights and the weight cage. I don't really replace those that often, but other than that, most of those are your common wear items. So it's not really any surprise that I have to replace those. It's just how it is. But so we will write these down. So I got gasket kit, liner and blades, weights and weight cage, top cover, metering valve, nameplate, transfer piston. And that's about it. It's like a, oh, and we also need so like on these Ford pumps, the mounting O-ring does not come in the kit. So you have to order that separate. Mounting O-ring. It's like gas kits. Most of these numbers I kind of know off the top of my head. Those I don't know. Top cover I don't know. That's determined. Basically now I just got to look at the breakdowns, look up these few last part numbers, write them down. I already printed out my test plan, so I don't have to worry about that. Get this wrote up, grab my parts, and then we're ready to start putting this thing back together. I got my new parts here. I'm gonna open them up and probably start with the head first since I'm up over here. And then we'll move these things around. So, with this pump here being a 3-cylinder, I have to do something a little different to the head than I would other pumps. I'm going to kind of put it together here real quick. So I stuck those pins in there to hold that cheek plate. And I'm just going to stick these plungers in here. Of course, with this being a 4 plunger, there's 2 long plungers and 2 short plungers. So you got to get them in right. I always try and make sure that all these rollers spin, because you don't want any of them locking up. Okay, so this rotor end gets torqued on here. However, since this is a 3-cylinder, you have to phase the end of the rotor to the rest of it. So, I have this special tool here. It's a long pin. So basically that pin goes through my port here and then lines up with my discharge port and my rotor. So now that won't spin around. The reason why I do that is because then I have this guy here, so you can see There's two little sections there. And those have to line up. So right now, basically I have one of those sections here and one section going here. So this section has to line up with my metering valve hole, which is right here at my finger. This section here has to be lined up with one of the vanes in the rotor. So right now, if I was to torque this down, it would not be in line. And basically what that does is, if for some reason this is out of phase too far, especially at high idle, at higher speeds, what'll happen is your rotor end might be lined up with a spot in your liner to where it's not going to be producing any transfer pressure. It's basically its charging side. So then you're going to have a very inconsistent delivery because your pressurizing side of the liner isn't going to line up with the discharge ports. So that's kind of a rough way to explain it. And I have to line these up. So on this one, since it's a clockwise pump, I can line it up with two of my cylinders. So even here, now the section I need is over here, but once I torque this down, this thing is still going to be off. So that means that I need to switch the end of that rotor out to one that'll line up. And it's one of those things you might think, well, it ran all this time like it is right now, you know, why couldn't you just put it back together like that? Well, it very well might run just fine, but it might not either. Yeah, see, now I'm a lot closer. So now my section's up over here. My vane is right here. So now once I torque it in, it's going to turn it that extra little bit to where it should line up. Yeah, and that's perfect. It's within my section. My section's right here. So that vane now lines up and everything is good to go. So now I can just torque it in like normal. Yep, that's perfect. So like I said, you know, it's one of them things that I could have put it back together the way that it was, and it might have worked just fine, but it might not also have worked just fine either. It's one of those things that, you know, in order to be a professional, you gotta do professional work. And here I'm just scribing this fuel plate to make it easier on the stand if I need to change my fuel. You can see that this slot right here, if I needed to adjust my fuel, I would loosen those two bolts and I would move that up or down depending on if I needed my fuel to go up or if I needed to go down. So that's why I just marked the inside so I can tell how much I've moved it if I need to move it. Got our new head O-ring. So basically that there is done. There is technically a roller-to-roller spec on these, like a Stanadyne pump. However, I never worry about it on DPAs. They normally are in spec or very close to spec. So I just don't have as much problems with DPAs not making fuel. So I just don't really worry about it. And if I need to adjust it on the stand, then I just do. So that's just going to sit right there for now. Have our housing here. We're going to mount this up. Then what I like to do just right off the bat is put my new seal in. This particular model of DPA, the seal comes in the kit. If you had a tapered shaft sticking out, those seals do not come in the kit. You have to order those. Got a special seal driver tool there. I don't have these very often that need those cushions, and I forgot to order them. Oh, there we go. There's my fourth one. Perfect. Never hurts to have a few spares. Saves me from having to leave my room right now. I can go grab them later. A lot of times you gotta force these in a little bit. So I'm using my rounded pick, not my sharp pick. Okay, so now I have my cushions in there, and now that center piece, that center driver is nice and tight. This is just a backing plate so those cushions don't fall out, but it does have to be lined up with the inner part because there's a blind spline here. So now, so you can see it right here, that blind spline has to line up with the inner blind spline, otherwise my drive shaft won't go through. Got our weights here, stick them in. Okay, all that looks good. Now I just gotta fish this thing through here. Okay. Not quite there yet. Here we go. Okay, so now that is together, but I'm still need to put in my O-ring. And basically that O-ring just holds everything together, makes it so it can't come apart. And I guess it does technically seal on the inside of your hub to keep fuel from coming through there. Okay, so now that thing there is built. Got our O-ring on there. Got our different weight cage. It's not new, it's used. And our different weights. This is his original hub. I'm just going to reuse it. I don't think it'll cause him any problems. Put our spring washer in there. And now, put a little bit of Loctite on this. I've never really seen one necessarily come loose, like if it came in from a customer, but it's how I was originally trained, so just never really hurts to be a little extra cautious. I just put a little bit of grease on that O-ring. Stick the drive shaft through. Now I can stick this through. Now I'm sure that some people who have done this themselves have always probably had a pain of a time. They probably clamp that in the vise or do something like that, but I have what I'm assuming to be a homemade tool, just by how rough the weld is. Regardless, I stick this in there, and now that keeps that hub from spinning. So now I can torque it in, and I don't have to worry about it coming out. Just another tool of the trade. So, works well for me at least. Hub is nice and tight, but it's not too tight. I have had issues where, of course, you don't want that to be too tight. You want some in play there, but also you don't want it to be too loose either. If for some reason it's too loose, then either it's not torqued down right or the inside of your housing is worn out. I've seen that too. We got that nice and tight. Got that in. This clip here is square on both ends. Sometimes one side will be square and one side will be round. And the way we always put them in is the round side follows the direction of rotation towards the square side. Where this one, since they're both square, it doesn't really matter. that, make sure that's all the way in. I have my test plan over there, so I know direction rotation, stuff like that. Cam looks good. It is a clockwise pump, so I have to put this in the correct direction of rotation. That's nice and free. Get our cam screw in here. I just torque it down now. I use the same tool that I use to take it off to put it back in. Put a little grease on the inside of my housing. Luckily, with DPAs, the head and the drive shaft can only go together one way. Basically, the only way you can get these out of time is if you put the cam in backwards. Other than that, there's no way to get the drive shaft out of time from the head. Because even if you were to take the top of the rotor off and spin it, the two bolts won't go back through because they're offset. So it's a lot harder to screw these ones up. Got our new advanced gasket here. This is something where I try and get everything kind of prepared before I put that on, because we are going to put some Loctite, some gasket maker on that advanced block, just so that way I don't have to worry about it leaking. Put a little bit of grease on these. So that's good. Washer goes with that. Now, this just needs a thin layer around it. And it's one of those things, you don't necessarily have to have this, It's not like they're going to leak every time if you don't do this. It's just something that I found gives me a little safeguard so I don't have to mess with it on the stand. Which we're going to do the same thing to the top cover gasket as well. Yeah, that's good enough. Stick our advanced piston in. These are also like Stanadynes in the fact of you got to torque your bottom head locating screw down first before the other ones. A little bit of dirt out there. Now I'm not going to torque down this bolt because I have to take that out to read my transfer pressure through there. Got that tight. I already put my advanced shims in there, so I don't have to worry about that. Grease on there. I just tighten these down. I've never really had too much of a need to torque them down. Transfer pump liner here. Stick that in the correct way. We got our new blades, or vanes, whichever one you want to call them. And our new O-ring. Our end plate here, I haven't done nothing with it other than just blast it, make sure it's clean. And we got our bolts. And these do get torqued down because, like a Stanadyne pump, you don't want to over torque them. They could seize your head. I will say, DPA heads are a lot less susceptible to being seized Very rarely do I find them with seized heads. So, got that built. Let's go stick this in here before I forget. Again, that there is just a bleeder to help you bleed it on the engine. So now we got our regulating assembly. This spring here, basically all it does, it keeps that piston from falling down. Supposedly it's to help also with priming. How much of that it really does, I don't know, but I know it keeps that piston from falling out. Gasket here. So that's on there. Now, this piston has to be free. Normally I kind of run it back and forth with a pick a few times. So I think it feels pretty good, and then I will with that. Yeah, see, now it's hitting both my fingers. So now I know that that is completely free. So then I put a little bit of grease in there just to hold that piston, just so that I can stick that spring inside there and I can drop it in without worrying about that piston falling out. Got our new screen here that goes in. We got our adjuster and our hold down spring, gasket. Now we got the governor. I did order a new metering valve, so it's brand new. Don't have to worry about that other one not performing. This goes in here. I just forced my weights back and get this in front of that thrust sleeve. Get that in there. And this should be completely free, which it is. As free as can be. Got our new little lock tabs. Like I said, whenever I tore it apart, I didn't reuse the old ones. There's no need to, since they come in the kit. I try and make sure these are a whittle straight, but it doesn't matter if they get a little crooked, just as long as they're not too crazy. Bend these little tabs up. Okay. That is nice and free. Housing's nice and clean. I'll put on this side cover. Luckily, I have pretty good luck with these Delphi gasket kits. They normally have everything that you need. There's a couple kits out there that I feel like, I don't know, maybe have a little less select than others, but overall, these ones normally are pretty good. Got our new O-rings for these. Got my little seal sleeve here. Helps push the O-rings on. A little bit of grease on this. Of course, this is where your throttle shaft goes, shut off shaft. Got that installed. Okay, now I'm going to give you guys some technical knowledge. So you have 3 holes in your governor plate, 3 holes in your throttle lever here. Let me bring this a little closer. Do that close-up action. So, you got 3 holes there, 3 holes there. Now, on DPAs, you have what's called a spring code. So this one here was in hole number 7. Which of course, some people will be like, well, what's hole number 7? Well, starting from the top governor hole in your furthest out hole on your throttle shaft is hole number 1. Goes in from there. So top hole goes 1, 2, 3. Second hole is 4, 5, 6. Third hole is 7, 8, 9. So, since this one was in hole number 7, and that's also what the breakdown calls for, I know that it's in the very furthest hole out and the bottom hole on your governor plate. Now, some people will think, well, what does that really do? Your different holes on your governor plate change your sensitivity. So, the furthest top hole would be your most leverage because it's the furthest away from your pivot point, and it goes obviously down from there. And then these 3 holes here change your lever position on your top cover. So let's say hole number 1 is here, hole number 2 might be a little bit further back, and hole number 3 might be a little bit further back yet. Because with this being in hole number 1 and hole number 1 here, you have the furthest distance. Throttle shaft is going to be in here crooked like this. So as you turn your throttle, you're pulling on this to make that spring extend. So then basically what's happening is if you go further up into your holes, you're shortening that distance between the two. So then at the same position, if you didn't change your throttle position, your spring would be tighter the further up it goes because you're stretching that spring out more. Got our new gaskets here. Then again, I just put a thin layer on this housing. Again, just to keep it from leaking. Especially since a lot of times these pumps come in with them leaking. So I hate to send a pump out that then they stick it back on their engine and it still leaks. That makes for a very unhappy customer. Okay, just like that. Doesn't really take a whole lot. Because you also don't want to put too much on there because then it squishes inside your pump and then it can hang some other things up. So I'm going to put my shutoff bar in here. Can't forget that, otherwise your pump won't shut off. I'm going to stick this in the correct holes per spring code. Stick my top cover on. Stick the shaft through. Line up. Shut off. Be good. Yep. Just like that. Now, like I said before, these are basically in principle very similar to a Stanadyne pump. However, they act a little differently in how the governor works. Mainly because a DPA uses a extension spring where a Stanadyne pump uses a compression spring. So, with a Stanadyne pump, you pull the lever to full load and it pushes on the spring, which pushes on your governor arm, which then pushes your weights back. Where with this, you're pulling on the spring, which forces the governor arm forward, which forces the bottom of the arm back, which pushes your weights back. So, in the same instance, on a Stanadyne pump, the metering valve goes forward to shut off, where on a DPA, the metering valve goes back to shut off. So, it's same principle, just a little different operation. Let's wipe the excess Loctite off, make it clean. These here are just little dust caps. Keep dirt from getting down in there. Sometimes this specific lever can be kind of a bear to get back in and lined up, especially if you have to take it apart. Because these ones actually use a breakover spring, where not a lot of DPAs do. A lot of them just use a solid lever, and they don't really worry about it. Now, I'm going to let you in on a little trick. An easy way to know if your shutoff is hooked up, which is on some pumps, not all of them, I will tell you that, is, so I pull this lever forward and just relax right now. If I move this, this lever moves. And that's how I know. Let's see if I can. So that's how I know that that is hooked up. Because whenever I push on this, it's pushing that shutoff bar back, which is then acting on that metering valve and acting on your governor arm. So that's how you can kind of tell if you got it all hooked up. And sometimes I can just kind of tell by feel, but that's just like a little easy way to tell if that's hooked up right. This is that part earlier that whenever I took it off, it didn't have a gasket on here, which I'm going to put a gasket on it because I don't want it to leak. It's got a little paint on here. It would probably be fine without it, but I'd much rather have a gasket on there than not. This hole up here is normally where a bleeder would go. This one here just has a bolt stuck in there, which doesn't hurt anything. It doesn't need the bleeder. It just helps get the air out of it. Okay, so we are basically done. I just gotta stamp it with our serial number. Okay, this pump is built. I'm not going to worry about these. I don't run them with those in it. I have different ones that I use just for the stand. I'm not going to worry about his fittings for right now. I am going to plug this off whenever I get on the stand. It's ready to go. Got everything set up here. Got that. This is just to keep, because there's going to be fluid that comes out of there. Got my inlet, got my transfer pressure, got my return. Injection lines. Got all them. Make sure they're tight, which they are. I had to switch injectors, which that's no big deal. Already had that set up, so we should be good to go to see what's going to happen. We got transfer pressure building up here, so it's looking good. And it's about ready to start pumping. I gotta let it warm up a little bit. Also, 3 cylinders are naturally a little louder. now I'm going to start running through my checks. Looking for transfer pressure. I need 8 pounds. I'm getting 14 and a half, so that's good. That's good. Perfect. Advance is working perfect, just like it should. Okay, cranking fuel is good. Check my shut off. Brings it down to 0 cc, so that's good. That also helps having a new metering valve too. Okay, so this thing here ran very well. Fuel was perfect. Adjusted my low idle and I adjusted my high idle to meet the RPMs and the CCs that needed. Shut off worked beautifully. Advance, I raised up my transfer pressure to bring it up, which is more than normal. Transfer pressure was right in spec, so I'm real happy with it. So I'm going to pull this thing off, get it back in the room, we'll air time it, and then cap it up and paint it. I got the pump back in here. Basically now all I gotta do is air time it, hook up his fittings back to it, and hook up the other stuff, cap it up, and then we'll paint it. So I got the air timing fixture, banjo, hooked to the correct cylinder according to my test plan. So then basically I just got to hook air to it. This here is a timing tool. It's basically a big degree wheel. I set this to the degrees that's specified. And basically here I go till it stops, and that is where I put my mark. Also, while I'm at it, I have to open up this side cover and move this over. Basically, I'm moving that clip, that big C clip that I had in there, to a letter in here. Sometimes it'll give me a letter, which this one does not. So I'm just going to put this to the closest letter and we'll call it there. So now this pump is basically airtime, which will then correspond with his timing cover on the engine. I'm going to put these fittings back on here according to how they came off, which I also marked before I took it apart. I put new O-rings on his fittings, so that way they won't leak. Okay, well that's pretty well it for me. Basically I just gotta clean it up and paint it now and paint seal it and put the tag on it. So I hope you guys liked watching me do a DPA. I'm sure Kurt's gonna finish it up and get it back to the guys over there at CNC. Hopefully they won't have no more troubles with it.
Welcome back to CNC Equipment's YouTube channel. Got my CNC shirt, my CNC hat, right? We're big fans of CNC equipment. Just a reminder, if you didn't come to us from Clint and Kevin and the boys over at CNC, please go over there and check them out. They've got some awesome content over on their channels. We're going to wrap this one up. This is the pump off of Clint's 4610 SU Ford tractor. You saw the whole gamut on the thing, right? Come in leaking and dirty, cleaned it up, tore it down, inspected it, got some parts, put it back together, rebuilt, calibrated, painted, and ready to go back to the boys at CNC for another cycle of life. If you want to see how this thing performs, go over there and check them out. There'll be a video on their channel. We'll link it below where they go through the installation and firing this thing up. Fairly standard repair and return on Clint's pump. This was a functioning and running pump. Keep in mind the complaint was basically making oil and leaking fuel. We did find internally, I know you saw it, Corey replaced the governor weights and weight retainer cage assembly. They were the most worn components, and then the top cover where one of the shafts goes through was kind of wallered out. Outside of that, it was pretty typical, right? Complete gasket kit, blades and liner, valve or two, and that was it. Let the master slap it back together, run it off on the test stand like you saw, and this dude is guaranteed to be good for another 4,000 hours. As per usual, this pump's going to go back to the boys with a standard issue load of YouTube swag, as does anything that comes from someone that mentions that you learned of us through our efforts on the YouTube. We have made a little investment into our YouTube efforts. We have taken the plunge into a modern GoPro. Don't know what version this is, probably 72 or 73. And we also have invested in Rode mics. For those of you giving us some feedback and constructive criticism, please know we're listening and we're trying to do our best to bring you good quality content. If you liked what you saw, do me a favor, drop Corey a comment down below, tell him that you appreciate his efforts. Corey is a fantastic representation of the excellence and expertise of the entire crew. He's one of the few that is willing to stand in front of the camera and demonstrate his craft. So give him a big thumbs up. Give Mallory a big thumbs up for dealing with all of our shenanigans and putting up with us and doing all of the editing. And the $1 million question, what did it cost? We're always very transparent with you, and we like to set kind of an expectation so you're not thinking you're going to get something other than what you're going to get at Area Diesel, which is always the truth, the whole truth, and nothing but the truth. This pump, Lucas, Delphi, CAV, DPA style rotary pump, has a ballpark average range in the $700 to $1,000 for a repair and return type situation. Keep in mind, your results may vary. The actual price is always based completely on specifically what your pump needs and the condition in which we receive it. But know this, we're fair, we're honest, and we're capable. This pump was in pretty good shape. It did have a couple extra hard parts in it, totaled up at $817.42. So for those of you curious, $800, normal range, $700 to $1,000. If you send us a basket case that's been sitting on the floor of the ocean, it could be well north of that. If you send us a cherry that needs just a gasket kit and some of Master Gracey's time, it could be less than that. But again, we're honest and we're fair. So if you need something, hit us up. Call us at 800-637-2658. You can log on to our website at AreaDieselService.com, where you'll have the ability to chat instantly with a diesel engine expert through the button in the bottom right-hand corner of your screen. You can drop us an email at parts@AreaDiesel.com, or you can send us a fax at 217-854-8972. And it's been a while since we've done it, so the first 3 of you that send us a fax with your name and address, we'll throw a little swag in a box and ship it out to you. So that's it for now. We'll be back soon. Thanks for watching.